Let's have some fun with vectors, shall we? But first, let's think about why we would use them. We are dealing with electrostatic forces right now, or will be. They are pretty important as far as figuring out how strong a resultant force is. So what is that? Let's pretend we have Susie and Sharon with really bad hair days, and they have a rope, and they're playing tug-a-rope. Tug-a-rope? Whatever. They're both pulling on the rope, and Sharon, so I remember who's who, Susie. Sharon's pulling this way on the rope, and Susie's pulling this way on the rope. So what we'll do is we'll say Sharon is pulling with a force of 3 newtons, where newton is a unit of force, and Susie's pulling with a unit of 5 newtons. What a resultant tells us is who's going to fall over. In other words, who's pulling hard enough to win the tug-of-war. How we denote this with vectors, make our little axes, is we'll say that one force is going this way, so we'll draw it with an arrow, and we'll call that one Sharon's force of 5 newtons, or 3 newtons, sorry. And Susie is pulling this way with a force of 5 newtons. You can look at that and say, why am I doing any sort of math? You've just made this really complicated for no reason, and I'm going to show you why, because it's going to get more complicated. So let's write something that we can see where it should go out, because what we're going to be doing is in components adding these things up, so we're going to practice making these into components. So first of all, let's name our axes. This is y and this is x. And you'll notice, even though Susie and Sharon are out on the lawn somewhere, we can move these vectors down onto an axis. Just call someplace 0 and tie each to that point. Makes it really easy to work with then. So let's start off with Susie's vector. Susie's vector of force is negative 5 newtons in the x-hat direction. So this is just telling us that this is a vector component. It has both magnitude and direction. It's on the x-axis going in the negative direction. And is there anything in the y? Nope. So we'll go 0 newtons in the y-hat. Now what about Sharon? Sharon's vector is 3 newtons in the positive x direction, so plus 3 newtons in the x-hat. And is there anything in the y? No, there's not. So plus 0 newtons in the y-hat direction. Now to get a resultant vector, we're going to add these two things up. Negative 5 plus 3 is negative 2 newtons in the x-hat direction. And 0 and 0 is 0. So this is our resultant vector. Oops. It's this negative 2 in the x-hat. So Susie's going to win, and Sharon's going to fall down. It'll be a sad day for Sharon. Susie might fall down too if she gets too much oomph going in the direction, but that's okay. Now, if we want the magnitude of that force, you can look at it and say, well, that's negative 2. But let's pretend we can't tell. I'm sorry, that it would be 2 newtons. The magnitude of the force is the components squared and the square root of that. So it would be negative 2 newtons squared plus 0 newtons squared. So this becomes positive, and the magnitude of the resultant is 2 newtons. So that's the strength of that resulting force, is 2 newtons. We're defining it as going 2 units in the negative x direction. So again, let's draw. I'm going to come back here, 1, 2, draw a little arrowhead, and this is where the vector actually lives. This is 2 newtons. So this defines its direction. This defines the magnitude, the length. This is going to make a little more sense because next we're going to do a 2-dimensional where we have pieces in the x and the y.